A large part of our sewer system is ageing and needs to be replaced in the coming years. However, replacing sewer pipe segments has a high societal, environmental and economic impact. This means we want to be clever about which sewer pipe segments are really necessary to replace and which aren't.
With our remote sensing background, we were thinking about several promising methods to inspect which sewage systems to replace without having to open up the ground. At the same time, we wanted to develop objective measurement protocols, and that is why we started the TISCALI project.
To get a first impression of potential problem areas without interfering in the street, the team looked at using thermal imaging and monitoring.
Leaks in sewer pipes create erosion voids, which are filled with air and water. These voids will react differently compared to the surrounding soil to temperature changes throughout the day. Even though this method looks very promising in a controlled environment, there is many variables that we need to take into account when applying this method in the real world. However, we can apply this method to point out problem areas that require further investigation.
To further investigate these problem areas, the researchers looked at using ground-penetrating radar at street level to more precisely locate the subsurface voids.
The ground-penetrating radar works by emitting electromagnetic waves into the ground by a transmitter. When these waves encounter materials with different properties, they are reflected back into the surface and are measured by the receiver. The collected data will help us construct images or profiles to identify different subsurface features, such as buried utilities, different soil layers, and erosion voids.
Once these methods are used to find potential problem areas, the leaks still need to be pinpointed to know precisely which segments need to be replaced. This can then be done with in-pipe inspections.
Traditionally, inspectors use regular cameras to look inside the sewer pipe segments. While visual inspection shows us where the cracks are, you cannot see whether the voids have already formed behind the cracks and also what their severities are. That's why we developed a new method, a robot that can tap inside the sewer pipes and record the reflected sound waves. By analyzing these recordings, we can create a 3D image of the pipe and its surrounding soil. This allows us to see precisely where the voids are and what their dimensions are.
Since this method is used in other fields of construction, bringing it to sewer systems looks very promising. However, it works best in wet soil conditions, which isn't always the case.
To complement the tapping method, we also used a small ground-penetrating radar that can go inside the pipe and works better in other soil conditions. This method uses the same principle as the street-level system. However, by putting the scanner inside the pipe, we are able to make much more accurate measurements on a smaller scale.
Combining all these methods, we are able to find potential problem areas more efficiently and in a more objective manner than visual inspection only. This means we are able to predict more accurately which segments need to be replaced without the immediate need to open up the ground. We hope to implement these new methods in a more routine manner to minimize the future impact of sewer pipe replacement.